Okay, so in this video, I'm going to talk about the law of cosines. So earlier in this series, which started with the law of sines, I reviewed congruence axioms and then when you can solve a triangle. And we've been talking about these four cases. So I'm not going to review them. If you've been watching the series, you should remember these cases. But the thing I wanted to say, so case 3 and 4, I have mentioned in previous videos that these cases use the law of cosines. So I'm assuming that you already know the law of sines. So I've talked about these previous two cases before. If you are not familiar with that, then it's going to make this video harder. So I would recommend just going back in this series and watching first about the law of cosines and the ambiguous case of the law of sines. I think I said law of cosines, sorry. Anyways, so case 3 and 4. So just to be clear, so this is where we have SAS, so side angle side or side side side. Okay, so a key for case 3 and case 4 is the triangle side length restriction. And what that is so the triangle side length restriction says that the sum of the lengths of any two sides of a triangle must be greater than the length of the remaining side. So this is just a thing with triangles. So that being said, because we know that that has to exist, I now want to talk about the law of cosines and how does this even come about. Okay, so we're going to start with an oblique triangle, right? Just like we did with the law of sines. And so we're going to view it in a very specific way. So I'm going to label the sides A, B, and C. And then what I want to do is I want to orient this triangle with a coordinate system. So I've kind of like laid that on top. And I'm a little strategic with this because I want one side of this triangle to lie on the x-axis. I want one of these angles to now be the origin. So I create my coordinate system where one of the angles will be the origin. And then this other angle is going to be one of the vertices. But so you can see, right, that everything's on the axis. Okay, so remember how we label the sides? So if this was angle A, B, and C, then this is little a, little b, little c. So this is just stuff that we know. So I just want to properly label things. And so with that being said, if I'm going from here, 0, 0, out to this point, angle C is at the point A comma 0, right? Whatever the length of A is, this is going to be the point A comma 0. So that makes sense, right? Okay. So maybe think about that for a second. So if we start here, we go a distance of A, then we're going to be A away, so that's A0. Okay, what next? Let's go ahead and label that point. That point's 0, 0. Now what about this point A? How would I get there? To get to that, what I'm going to do is I'm going to think back to my right triangle trigonometry. And so just notice here I've got this triangle that I can make like this. And from this triangle, I can figure out the points the points that A is sitting at. Okay, so let me draw a little illustration here. Let's think about this in terms of the angle B, okay? So if I wanted to find the sine of B, so sine is opposite over hypotenuse. So if I'm here at sine, this is the opposite side, y, and this side here, this is the hypotenuse of that right triangle that we've created, so that would be C. And then for cosine of B, so it's going to be x, so adjacent over hypotenuse, so x over C. All right, so I bring this all up because this is going somewhere. Okay, so once again, just remember, we're starting at the origin here. And from the origin, I've gone out some distance x and up some distance y. So for now, I am going to call this point xy. But this is not ideal because I had to create this new right triangle to help me get to this point. So what I really want to do is I want to be able to label this point here in terms of the triangle that we started with. So in terms of A, B, and C. And so by making these connections that we've made, so sine of B and cosine of B and everything that we've done so far. So now what I can do is I can actually solve. So I can solve for y and for x so that I can better label this xy point that we had. We want to get rid of the xy and we want to get it back in terms of just a, b's, and c's. So to solve for these, to solve for y, I just multiply both sides by c, and same for x, right? I just multiply both sides by x. And so now I have a point x comma y, except I can represent it now in terms of the triangle. So I can rewrite this point as c cosine b, c sine b. Kind of cool, right? Clever. Clever is what I'd call that. All right, so now what? So now we have a fully labeled triangle. Cool. And so here's the question. How can we find the length b? Now I could have started with any length. I'm just kind of like just saying, let's start here. Let's say, how do I find this length b? How would I do that? All right, so to do that, we're going to use this like little triangle. So this triangle we'd made here before. What we're going to do now is we're going to take this right angle and we're going to extend it so that we kind of have like this, what I like to call a sneaky right triangle. And we're going to use this now to help us figure out what length b is. Because if this were a right triangle, right, then we could all go home here. This becomes very easy. So I can figure out b because it's just the hypotenuse, right? No problem. All right, so we can use the Pythagorean theorem to help us out. So to figure out what is this length b, it's really just using the distance formula, right? So with the distance formula, so I take this y coordinate minus, so this point minus this point. That's really what we're getting at. So I take this y coordinate minus this y coordinate. So c sine b minus 0, and then I square it. And then I do that the same thing with the x's. So c cosine b minus a. Okay, so that's where that all comes from. So we're trying to find this length here. We're just using the distance formula to do that. And so now let's slog through a little bit of algebra here. So I will, I want you to do this alongside of me because I think you can get this sense of wonder if you work through this a little bit and really appreciate like how magical mathematics can be. Okay, so first things first, let's square both sides. And now when I square both sides, so I don't have to write this as c sine b minus 0, right? I can just write this as c sine b because the 0 is redundant. All right, so the next thing that I want you to do, just so that you can kind of keep up with this, is I want you to square everything. So this, you're going to have to take c cosine b minus a times itself. So you're going to have to FOIL this out or whatever. So go ahead and work that part out. And after you've done that, are there any trig properties you can use to simplify this? So see if you can figure out what the result is here. Even if you don't get it all the way, that's totally fine. But you're going to get a better sense of wonder, which mathematics has a lot of wonder with it. I mean, I hope you get that out of my videos. I have a sense of wonder with it. So I want you to have that sense of wonder. And the way you do that is you kind of fumble around like I'm telling you to do right now. So you try, hit play when you feel stuck or you're not sure what to do next. All right, so, okay. I'm going to square everything. So I've got this as c squared sine squared b, and then I multiply out this whole part so you can see what the result is. So remember, you have to take this times itself. So you've got to FOIL everything out. So here's the result I get. Okay, so when I look at this and then I put my trig identities hat on, I see this sine squared b plus this cosine squared b. I feel in my heart what I must do. I must put those together somehow and use that sine squared b plus cosine squared b equals 1. Okay, so what I'm going to do is I'm going to do basically that. So these both have a c squared attached to them. So I'm going to factor out the c squared, and I'm left with this. And then I have the rest of this stuff. Okay, so 2ac cosine b plus a squared. Okay, so now what? Well, this guy right here, right, this is what I said in my heart of hearts I wanted to do. This equals 1. All right, so now I can rewrite this whole problem as you see here. So I've got c squared times just 1. Cool. I love that. I love when that pops up and then it makes everything look nice. And believe it or not, now actually we are there. We have proven what we've wanted to prove. So the law of cosines, one part of it is what you see right here. B squared equals a squared plus c squared minus 2ac cosine b. So this is just one of the forms of the law of cosines. So like I said, I kind of just arbitrarily kind of like chose some sides to work through. We could work through the other sides and get a similar result. So I'll just tell you now, what is the law of cosines? So you can have any triangle ABC with sides A, B, and C, and the law of cosines is these three formulas here, which maybe I would suggest you write them down and then let's talk about them. So hit play after you've written them down. Okay. So, you know, I think I've said this before. I have the memory of a hamster. So I, like, there's a lot of letters. So I'd be pretty nervous, I think, of like having to memorize these. But here's the nice thing. Here's how I remember this. So you have the side that you're looking for, and that is found by taking the other two sides squared minus 2 times those same sides times cosine of the side that you're, the adjacent angle that you're looking for. So I know this seems like a lot of letters, but actually I think that like visually this actually makes a lot of sense. So even though the formulas look hard, I think it's once we get rolling here, you're going to be okay. All right. So believe it or not, we've been using the law of cosines for forever. This is some random party trivia for you. The Pythagorean theorem. Have you heard of it? I think you have. So the Pythagorean theorem is actually just a special case of the law of cosines where C is equal to 90 degrees. So if I go back to this little formula here, so a lot of times with right triangles, we always call C the hypotenuse. So using this formula here, I'm going to replace the angle C with 90 degrees. So what happens? So what is cosine of 90? Well, cosine of 90 is 0, right? So what happens is this whole part here falls out. So what am I left with? Our beloved c squared equals a squared plus b squared. Oh my God. So I know you cannot wait to tell somebody at a party about that. You're welcome. You're welcome. Subscribe to the channel. Okay, let's go on. All right, so let's use the law of cosines. So we're going to solve some other triangles. Okay, so I've got the information, I've got this angle, and I've got the two sides. So, okay, you know how this works. We're going to draw ABC, we're going to label the sides, and then we're going to label the angle. So I would recommend that you just take a second to do that. Now, once you're at that point, I do just want you to appreciate the situation. I've got a side, an angle in between, and then another side. So when you have this set of information, then you are all systems go for the law of cosines. Okay, so I want to figure out the side b squared. So if I'm looking at, and I'm trying to strictly follow my formulas, in the law of cosines, I want to use this version of the formula here. Okay, so I think this is where I can kind of make a little bit more sense of this to you as to like why you don't actually have to memorize this. So we're going to use this and we're going to just boop, take that and just plug it in. All right, so a squared plus c squared. So that's information that we were already given, right? Minus 2 times the information we were already given times cosine of the angle we were given. And that will help us find the last remaining side. Do you see that visual connection? So you're literally just squaring the two sides that you were given, minus 2 times those two sides, and then minus cosine of the angle you were given. This is pretty easy to remember when you have side, angle, side. It gets a little trickier with side, but we'll get to that in a moment. All right, so that's the situation. So I just plug in all my information and then it's just plug and chug, right? So just make sure your calculator's in degrees. So if I go ahead and work this out, so I get b squared is equal to 2,107.24. Take the square root, I get 49.5 feet. And so boom, now I've got my side B. All right, so I've got side B. What about the rest of the triangle? Well now, and this is why I said you need to know the law of sines. From here you can just use the law of sines to finish this. So I'm going to use, side B over angle B, or sine of angle B, so as you see here, equals, and then it doesn't really matter which angle I want to choose. Oops, I dropped my C. This is angle C. So this over angle C, which I dropped the C on, sorry. And so now I can go through and figure this out. So sine C is going to be equal to this. And so then I can plug that in my calculator. So I get sine C equals 0.91996. Then I take inverse sine of this result. And so I ultimately get that C is equal to 66.92 degrees. Cool. And so then now I've got C. So I want to find the last angle, A. So now I can just take 180 minus the other two angles that I found. And then I get angle A. And now I've figured out everything else on the triangle. So there you go. Okay, so let's contrast that now to when I have side, side, side. So I have triangle DEF. I've got D is 24.2, E is 42.6, and then F is 59.1. So once again, I'll draw my triangle. There's everything labeled. Okay, so this gets a little trickier. We can still use the law of cosines, but as far as like which formula do you choose, it really doesn't matter now. And again, we're like now in DEF. And so this is where I think it can get really confusing with like all these different letters running around. So I just grab one of the random formulas here. Like I said, I really think of this as, so let's say that I want to find, let's say that I want to find D, angle D. So if I want to find angle D, so I now know all three sides. So remember, angle D, if you're trying to find angle D, then the whole equation is going to equal that opposite side. So that's 24.2. So then the rest of the formula goes the other two sides squared, so 59.1 squared plus 42.6 squared, minus those same two times those same two sides, times cosine of that side's adjacent angle or opposite angle that you're trying to find. Is that making a little bit more sense? I hope it is. Like I feel like visually this formula makes more sense after you use it a little bit more. At least that's how I felt about it. All right, so anyways, now we got to do a whole bunch of math here, right, to figure this out. So I am just going to show you, boom, here is the math I did. So I would say that you should pause and just make sure that like you are algebraically jiving with me and that you agree with this. So I would, like I said, pause, just make sure you're good with this, and then continue on. So I get that cosine of D is equal to this, and so then I just take inverse cosine, so I get D is equal to 20.32 degrees. Okay, so that is one angle of this triangle, so we still have to find the other angles. So D is equal to 20.32, and from here I can use the law of sines. Now, I think that this would be a good time for you to pause the video and see if you can finish this, and this is a good review of the law of sines. So I highly recommend that you pause here, you give it a try, and then you hit play when you're ready. So, okay, so now I'm going to keep going with this. So I'm going to find angle E, and so go through the work here. And so here's how I isolate sine of E. So then I get that sine of E is equal to this decimal. So E ultimately comes out to 37.6 degrees. And then now I've got D and I've got E. So then to figure out that last angle, F, I take 180 minus those other two, right? And then I get the last angle. So obviously this triangle is not drawn to scale. I never think of the triangles as being drawn to scale. That's like a thing you get really paranoid about. You never make that assumption after a while. Okay, so got it? Good. All right, so let's look at a couple of applications that, you know, are just using the law of cosines. Okay, so I've got two boats leave a harbor at the same time, traveling on courses that make an angle of 81 degrees and 30 minutes between them. When the slower boat has traveled 65.2 miles, the faster boat has traveled 84.3 miles. At that time, what is the distance between the boats? Okay, so this situation is it seems a little complicated. So the boats start here and they take off in their respective directions. So this boat 2 goes this way and boat 1 is going this way, and they create this 81 degree and 30 minute angle. So this boat has gone 84.3 miles and this boat has gone 65.2 miles. And now I want to know, what is this distance between them? Well, notice, my friends, side, angle, side. So really, we just have to figure out then this other side. We'll call this side C. And, personally, I think you can do this. So I would pause the video here. I would try to apply the law of sines and see if you can figure it out. And if you get stuck, that's totally fine. You'll get way more out of the video, though, if you do give this a try. Okay, so I'm going to use the law of cosines. So I could, if we want to split hairs here, I'm going to use this formula. So I can just go ahead and kind of write that down. Okay, so I want to find side C, and I know angle C, and then I know the other two sides. So again, just notice, so I take one side squared, the other side squared, minus 2 times those two sides times cosine of the angle that we were given. And so now it's just plug and chug with the algebra, or I guess trig. Anyways, just, yeah, go through and finish it. So I get that C equals 98.65 miles. Okay? All right, and let's just talk about one other type of application. It's still just using the law of cosines. So let's say I've got a roof truss. So the simplest type of roof truss, I cannot speak, is a triangle. So I want to find angle C to the nearest degree for the truss. Why can't I say that word? Shown. Okay, so here's angle C if you can't see it. So I've got some information. I think this is kind of a weird looking roof. I don't know if roofs would actually be 10 feet on one side and 7 feet on another side. If you're a roofer and if I've offended you, I am very sorry. Okay, so law of cosines. So just notice here, this is really like a side situation, right? And I want to find this angle here. So if I want to find this angle here, what my equation needs to be equal to what? It will ultimately need to be equal to 10 feet squared. Right? From the formula. That's kind of what I've been trying to get you to see. So anyways, I think you guys should try this and then, give it a go. Hit play when you're ready. Remember, math is not a spectator sport. All right, so I've got the law of cosines just in case you need it. So if I wanted to, think in terms of strictly these formulas, I'm going to use this one here. Again, I'm kind of more visual, but anyways, so I'm going to use this formula. So remember, I'm trying to find this angle. So the whole equation is going to equal this side squared, 10 squared. Then I take the other two sides squared minus 2 times those two sides, and then times cosine of C, which is what I'm trying to solve for. So now I've got to isolate cosine of C. So to do that, I'm going to get that this is 49 plus 144 minus 100 divided by 2 times 7 times 12. So I get cosine of C equals this decimal here, i.e. C will equal, to the nearest degree, 56 degrees. So I can round down from the 0.3. Okay, so at this point, I have talked about all the different types of cases with triangles and how to solve. So I thought I would just do a really quick review of all those cases that we've talked about. So case 1, that was when we had one side and two angles known. So that was like side angle angle or angle side angle. So in these cases, this was really the first video in my series. So you'd want to find the other remaining angle. Pretty easy, right? If you know two angles, you can easily find the third angle. And then you can use the law of sines to find the other sides, and you didn't have to worry about like the ambiguous cases. Okay, what about case 2? So this is where you have two sides and one angle, but the angle is not included in between. So you have side angle. So this could make more than one triangle, and that was the whole video that we had. So when you have case 2, so you want to find one of the other angles using the law of sines. And from there, then you have to determine if there is ambiguity. So you do have to watch out for what type of case you have. And then if you have two possible triangles, then you're going to have to solve 2 of them. But then you solve for those other cases, so you can take 180 minus the other angles to get the remaining angle, and then use the law of sines to get the other side. So just be careful. If there's ambiguity, then maybe you have to solve for 2 different triangles. And then we had case 3, and with case 3, so that's what this video is about. So we can find, this is where I have side, angle, side. So I can find the last side with the law of cosines, and then I can use the other measures using the law of sines or taking 180 minus the other angle measures. So you kind of know where to go from there. And then finally we've got case 4, so that's where we've got side, side, side. So when that happens, so you're gonna find one angle using the law of cosines, and then from after you find one angle, you can use the law of sines to find the other sides and angles. And then of course when you know two angles, then you can take 180 minus the other two angles. So you just kind of go on from there. Okay, so you do need to know which case you're in, right? I do want to make that really clear. You've got to know which case you're in because that's going to dictate how you solve it. When you have side angle angle or angle side angle, then you can just use straight up law of sines. When you have side side angle, that's where you have to worry about the ambiguous case. And then cases 3 and 4, so you've got to start by using the law of cosines. So you might want to actually like try to memorize this list, or do something to kind of remember like how do you approach these. Okay, so otherwise, if this was helpful, consider liking, commenting, sharing with your friends, subscribing to the channel. I am trying to provide high quality math help to all, and I have pretty big plans for this channel and my website eventually. So anytime you guys like a video or subscribe, that is super helpful and motivating to me. And otherwise, thanks for watching, guys. I will catch you next time.